There is a type of equations that was difficult to solve, and that was a to the power of x equal to b. Now, for straightforward, problems like 2 to the power of 2 equal to 4, this was easy enough. And the problem was when the exponent was a non-integer, right? Say for example 2 to the power of 1.73 equal to what? This was one type of question that was difficult to answer or to calculate. And the second was x to the power of 1.73 equal to 5. So to answer this question, a whole system of logarithms was created. Now, we will not start with such difficult problems. We'll start with something simple so that we can understand the concept behind logarithms. Okay, so let's see. 2 to the power of 1 equal to 2, 2 to the power of 2 equal to 4. Now, how do we reverse this? Basically, the idea is to come out with something to the power of what is equal to, let's say, 32. Let's say 2 to the power of what is equal to 32. Now remember, this example is simple. To understand the concept, we are looking at this. But 2 to the power of what is equal to 7.32. It could be that also. So how do we exactly write this? So we would write it as log to the base 2 of 32 is equal to what? Of course, we know that this is equal to 5. 2 to the power of 5 is equal to 32. So log to the base 2 of 32 equal to 5. Okay. And to solve this type of problems, a whole logarithm table was created. And the basic objective of creating this logarithm was to convert powers to multiplication, multiplication to addition, and division to subtraction. Okay, now let's look at some special cases. Now we know 2 to the power of 1 equal to 2, 2 to the power of 2 equal to 4. Let's go backwards. 2 to the power of 0 is equal to what? We know it is 1. Similarly, so one of the things is that a to the power of 0 is equal to 1, which implies log to the base a of 1 is equal to 0. That is this. Now let's look at this. A to the power of 1 is always equal to a, which implies log a to the base a is always equal to 1. Can we take it further back to negative numbers? Let's look at an example. Let's say a is equal to minus anything. Let's say minus 2, or let's say minus 4 to keep it simple. Now minus 4 to the power of 2 equal to 16. Now converting into logarithm, log to the base minus 4 of 16 equal to, so this is perfectly fine. But what if the right hand side is a fraction? Say log minus 4 of x equal to half. Now what is x? Now x would become minus 4 to the power of half, which gives us square root of minus 4, which becomes 2 root minus 1. which becomes 2i, which is an imaginary number. Now, because when we go for a as negative, we get into imaginary numbers, a should be greater than 0. Now let's take another one special case, that is a equal to 1. Right? 1 to the power of 1 is 1. 1 to the power of 2 is also 1. 1 to the power of 3 is also 1. So if a is 1, a to the power of anything is equal to 1. So this we can treat it as an identity and put a condition that a cannot be equal to 1, because we don't get a unique solution for this. Here x can be anything. So a has to be greater than 0 and a cannot be equal to 1. At the same time, b, if a is greater than 0, then b would also be greater than 0. It is very important to understand the concept of logarithms, because once we get into calculus, there it is extensively used. Okay, so I think that's enough for today. Bye for now.